Moving forward with our simplifying square roots, everybody, while these problems might look different on the surface, you're going to see it's really the same idea. So here we go. I sketched out some rough lines just to pair the problems up because it'll be like that on the assignment. So looking at 1 and 2, you can see there's multiplication involved. So the first thing I would do is multiply. 15 times 3 is 45. Don't lose the square root sign. Now, from here, you do what we were doing before. Find the greatest perfect square in 45, which is 9. It's the only perfect square that goes into 45. Take the square root of 9, which is 3, and 5 stays under the radical. So the only extra step here is you multiply. Same over here. Now they're written as two separate square roots. You can still multiply them. And 12 times 2, square root of 24. Again, greatest perfect square in 24. In fact, the only perfect square in 24 is 4. So from here, 2 times the square root of 6. So you see it's very similar, just multiply first. Let's go to 4 and 5. Now there's a number sitting outside the radical. That means multiply. So that says 5 times the square root of 63. So you pretty much ignore the 5. And you do the problem like you've always done. The square root of 63 has a perfect square in it. 9. 9 times 7. So 5 is just kind of riding along right now. Don't leave it behind. So I'm really just doing a regular problem. Okay, see if I cover up the 5, it looks like what we were doing on the last assignment. So now in my last step, I have to multiply the 5 and the 3 together. So to summarize this, that number just rides along to the end and then multiplies to the number that you normally have sitting first in your answer. So again, at any time you can pause the video and try the second problem because they pair up. But I'm just going to go ahead and have a two different square roots. I think we've seen this number a couple of times. 9 does go into that. 4 and 9 go into that, but if 4 and 9 both go into it, I always check 36. So in fact, that is 36 times 3. Again, just bring 2 along. That's multiplication. The 6 came from the square root of 36. And then right here, I just multiply these two to get 12 times the square root of 3. Okay? So not a big change. Just deal with that number on the outside last. These two are different. So you could multiply all that together. The problem is sometimes those numbers get very big. If you look, you will see we have a pair of 2's. 2 times 2 is 4. That's a perfect square. You also see we have a pair of 5's. 5 times 5 is 25. Now the only number left under there is 11. So I have to keep track. So now the square root of 4 is 2. See, it's a perfect square. The square root of 25 is 5. Bring along the square root of 11. And now, since I have two numbers there, I will multiply them to get my final answer. A little different, but still similar. Okay, number 6 follows a pattern 2, where we look for a pair of numbers, and there we have 7 times 7. And look at the two numbers that are left. We have a 5 and a 2. Just multiply them together, because they don't have a pair. And now the square root of 49 is 7. That 10, I can't do anything with it. Okay, we're going to look at a couple fraction problems. We'll just do 2. There are 3 of them on here. I'll finish the third one and then just send it as notes. I'm going to make the notes and the assignment one document. Maybe you can try it and see how you did with it. Now don't panic when you see the fraction. I have all this set up. Save us a little time. So first thing, you're going to make it 2 separate square roots. Okay, just like that. Now look at the denominator. That's a perfect square, and that will be that way on all of these. So I just take the square root of 49, which is 7. I'm done with the denominator. The numerator, I just simplify like I've always been simplifying. Perfect square in 40 is 4. Take the square root of 4, and that's 2. And just bring the 7 over. So I think you should be okay with these. We'll do this one. But again, first step, make it 2 separate square roots. Take the square root of the denominator, you're done with the denominator. The numerator, the greatest perfect square in 99, is 9. And the square root of 9, that's going to become a 3. And again, it just sits over top of that 4. Okay, try this one. I'll finish it, and that's it. So there are some different features to this, and at the bottom, if you see that 4, I just have the perfect squares on here, and they'll be on there when you see these notes. Okay then, 50, 81. Just break it up. 81, the square root of 81 is 9. I'm done in the denominator. 50, 25 is the perfect square in 50. Don't divide by 2 all the time. Someone did that in the last assignment. The square root of 25 is 5. And I'm done. Okay, so on the back of this is the assignment. And you see it's the same thing. These 3 are just review, like the assignment before this. And then you'll see a section of problems where a number is in front. Okay, refer to the notes if you have to. There are 2 of these, where you look for the pairs. These 2 you'll multiply. And finally, there are 2 fraction problems. It's just a one-sided assignment. It's not very long. But show work. Try to set them up the same way I did to get full credit. If you have any questions, let me know.